Hello student, welcome to all of you in the next physics lecture. This is the chapter number 2, Mechanical Properties of Fluids, and video number 19. We have to see here the next point, the capillary action. First we have to see what is meant by the capillary. A capillary is nothing but a tube having the very small nice bore is called as the capillary tube. And if the one end of this capillary tube is dipped like the liquid like the water, then it is observed that the water rises in the capillary so that the liquid level rises inside the capillary. Is called as the capillary tube. What is meant by the capillarity? Because there is a difference in between the capillary and the capillarity. Capillary is a simple tube which have the nice bore, and if this capillary dip into the liquid like the water, then the liquid level inside the capillary, which should be the rises than that of the liquid level. This is the function of the capillary. But capillarity is nothing but the phenomena of rise or fall of liquid level inside the capillary tube is called as the capillarity. We have to see here the capillary action. But before that, we have to see what is meant by the capillarity. In your exam, sometimes define the capillarity. If you have to ask the capillary, then capillary is nothing but what? It is a tube having the small nice bore, which is called as the capillary. But capillarity means what? Which is the function. So this is nothing but the phenomena of rise or fall of liquid level inside the capillary tube is called as the capillarity. For example, blotting paper absorbs the ink or water. Clothes soaks the water due to this capillary action. Or ink rises the pen. This is the example of this capillarity. And a natural example that root absorbs the water from the soil, and this liquid level of this water, it should be, you have to see in the several branches of the trees. This is a good example of this capillarity. Then from this capillarity, we have to see the capillary action. That means we have the question, why the liquid level inside the capillary tube rises? What is the reason? And this reason is nothing but the capillary action we have to see here. For that point, we have to consider a capillary tube, and which is dipped into the liquid like the water. We have to see here in this diagram the capillary tube, and which can be dipped into the liquid like the water. Then this liquid level rises, which is not shown in our figure. But there is the exceptional case, because in our definition, the phenomenon of rise or fall of liquid level inside the capillary tube. All the liquid in which the capillary tube insert, then the liquid level rises. But exceptional case, mercury. In mercury, if you have to insert this capillary tube, then the liquid level fall off as compared to the liquid level. And so that we have to say here the phenomena of rise or fall of liquid level inside the capillary. Here we have to take the capillary tube, which can be dipped into the liquid like the water, and here we consider the 4 points A, B, C and D in such a way that the point A, we have to write here, these 4 points are such that the point A is just above the curved surface but inside the capillary tube. Point B is just below the curved surface inside the capillary tube. Point C is just above the plane surface outside the capillary tube. And point D is just below the plane surface outside the capillary tube. That means we have to take here the point A and B inside the capillary tube, above and below the curved surface. We have to take here the point C and D, which are outside the capillary tube, just above and below the plane surface. These are the 4 points we have to consider here to see the capillary action. Now, this point PA, PB, PC and PD we have to consider here. Let PA, PB, PC and PD. These are the pressure at these 4 points respectively. Then we have to consider here the curved surface, and which is nothing but the point A is just above the concave surface, and we know that the pressure on the concave surface must be greater than the convex surface. By using this condition, we can write the PA, that means pressure at point A is greater than the pressure at point B, because this pressure at the concave surface must be greater than that of the convex surface, so that we can write here PA is greater than PB, and this is the equation number 1. Now the point C and D here, as shown in diagram, the point C and D which are at the plane surfaces and there is no pressure difference, we have to see. Therefore, the pressure at point C and D are the same. Therefore, we can write here the PC is equal to PD. This is the equation number 2. That means the pressure at point C and D are the same. Therefore, we can write PC is equal to PD. This is the equation number 2. Again, the point A and C are at the same atmospheric level. Therefore, pressure at the point A and C are also same. Therefore, we can write the PA is equal to PC, equation number 3. Now compare the equation 2 and 3. See here, PA is equal to PC and the PC is equal to PD. That means instead of PA, we can write PC, and again PC is equal to PD. Therefore, PA is equal to PD. We can write from equation 2 and 3 the PA is equal to PD, because PA is equal to PC and PC is equal to PD. Therefore, PA is equal to PD. We can substitute this PA is equal to PD in equation number 1, where to obtain the value of PA is equal to PD, and this PD can be substituted in this equation number 1 instead of this PA. Therefore, substituting this equation 4 in equation 1, we get instead of PA, we can write PD. PD is greater than PB. Now see in the figure, pressure at point D is greater than that of the pressure at point B. Though these points are at the same level, B and D are at the same level, but the pressure at point D is greater than that of the pressure at point B, so that the liquid outside the capillary, due to this greater pressure, which can be inserted inside the capillary tube, up to which the pressure at point D and the pressure at point B, which are the same, because the pressure at point D which is greater than that of the pressure at point B, so that this liquid is not in equilibrium position, and so that to equilibrium position, the liquid outside the capillary, which can be enter inside the capillary tube, until up to which the pressure at point D and B are the same. This pressure at point B and D are the same, then this liquid outside the capillary, which can be entering into inside this capillary tube, it should be stopped. But at that time, the liquid level inside the capillary, it should be the rises. Liquid level inside the capillary tube, it should be the rises, up to which the pressure point B and D are the same, and this is the reason why the liquid level inside the capillary tube rises inside the capillary tube. This is the reason. Sometimes you have to ask that why the liquid level inside the capillary tube should be rises, and this reason you can be the give with the help of this diagram and this equation. Okay, you have to understand this capillary action. Okay, thank you.